In this video, we will learn how to integrate Kafka into our microservices project and see how to build event-driven microservices using Apache Kafka. We'll also integrate some best practices like using Schema Registry and also learn how to write integration tests when you are dealing with Apache Kafka and Spring Boot. So without any further delay, let's start the video. Alright, so let's start by learning what is Kafka. So Kafka is a distributed event streaming platform or a messaging platform which is used to build event-driven architecture, event-driven applications. So this is a very widely used software in the industry right now. So whenever you are going to use a messaging platform, you will have an option to use Apache Kafka because it's very reliable. It has some features like high availability, so it can have highly available clusters set up across different availability zones. And also the core feature of Kafka is it provides a permanent storage of the messages, and of course it is very scalable and it provides very high throughput of messages. So if you're new to Kafka, I suggest you to go to this kafka.apache.org website and explore about Kafka. We will mainly deep dive into how to integrate Kafka into our project and with Spring Boot. So to integrate Kafka with our application, Kafka with our project, we'll be mainly using the Spring for Apache Kafka library. So it provides good abstraction and libraries to integrate with Kafka. We have some Kafka template which enables us to easily send messages to the Kafka topic, and also Kafka listener annotation, which creates a listener which will read the messages from the Kafka topic and helps us to process the messages. So we'll also see how to use this library. So if we go back to our architecture diagram, you see that our order service will be making the asynchronous communication with the notification service. So we'll be using Kafka here for the asynchronous communication. So what I'm going to do now is to enable the Kafka integration in the order service, and after that we will create the notification service, which is actually sending out emails to the customer by reading the messages from the Kafka topic. So now let's open the order service. Alright, so I'm inside the order service project, and the first thing I'm going to do is to install Kafka in our project. So for that, I'm going to open the Docker Compose file, and I've already added some Docker Compose, some services to the Docker Compose because it's easy for me to just explain this Docker Compose file instead of you watching me type all the services one by one into the Docker Compose file, right? So what you have to do is just go to the blog post, which will be linked down in the description section. So if you go to the blog post here, in the first section, installing Apache Kafka through Docker, you can just copy the whole Docker Compose file. It contains all the necessary services to run Kafka. So if you go back to our IntelliJ, you can see that the first service we have is Zookeeper, something called as Zookeeper. So Zookeeper is also an Apache project. So this is mainly used to orchestrate different clusters of Kafka, right? So Kafka can run in a clustered environment, as we saw in the previous in the Kafka website. It's highly available. That means it runs across different clusters. So Zookeeper acts as an intermediary where it manages different clusters, right? It manages the state of different Kafka clusters, and it has centralized storage to manage state of the Kafka clusters. So Zookeeper is used mainly as an orchestrator. So that's why we need Zookeeper. So for Zookeeper, we are using the image Confluent Inc. CP Zookeeper version 7.5.0. And I'm going to call the host name as Zookeeper and the container name as Zookeeper. And of course, I'm also going to expose the port 2181. So this is the port in which Zookeeper will be running. So I'm going to expose Zookeeper on the same port. And finally, I have two environment variables, Zookeeper client port as 2181 and Zookeeper tick time as 2000 milliseconds. So this is the configuration for Zookeeper. In the latest version of Apache Kafka, there is no need to use Zookeeper anymore. You can use something called as Kraft, but I'm not going to use that right now. Just as an information that you can also use Apache Kafka without Zookeeper. So next comes the service Kafka itself. So I'm going to call this service as broker instead of Kafka as broker, and we are going to mainly use the image Confluent Inc. CP Kafka 7.5.0, the version 7.5.0. The container name is going to be broker, and here I'm going to expose two ports, 9092 and 29092. And this Kafka service depends on Zookeeper because before running Kafka, it needs to register itself with Zookeeper. So that's why we depend on this container first. And we also have some environment variables, the Kafka broker ID, which is uniquely identifying the broker. And after that, we also have to provide the environment variable to which service the Kafka should connect for Zookeeper to register itself with Zookeeper. So for that, we have Kafka Zookeeper connect environment variable, which is we are providing it as the container name Zookeeper followed by the container port 2181. Finally, we have some security configuration like Kafka listener security protocol map. So here, as we are using just in the local development, I'm just going to provide the security protocol as plain text. So, or else you can use SSL and TLS security protocol when you are using it for production. And we also have Kafka advertised listeners. That means these are the listeners where Kafka is accepting the connections, right? So we have two listeners, plain text on the name broker 29092, and for the plain text host, localhost 9092. So mainly if you are communicating from one container to other, so if you want to access Kafka from one container, from a different container, you will usually use this 29092 port. And if you want to use this from your localhost machine, you use localhost 9092. So that's why we have exposed two ports, 9092 and 29092. Finally, we have the Kafka offsets topic replication factor environment variable. We are going to set it as 1. And we have another service here called as Schema Registry. I'm going to come to this part later. So let's to make you understand why we need Schema Registry, first we have to try to develop the logic to send out messages to Kafka from our order service, and then we will come and enhance it with Schema Registry. So lastly, we have the service called as Kafka UI, which provides a nice UI where you can view the topics and the messages which are there in the Kafka topics. So for that, we are going to use the image Kafka UI from Provectus Labs. I'm just going to use the latest image, and I'm going to run this container on the port 8086. Internally in the Docker container, it's going to run on the port 8080, because as we are already using the port 8080, I'm just going to map this into a different port 8086. And this Kafka UI is going to depend on the broker and the Schema Registry, because it needs both of them before we run this application. So for now, we can just remove the dependency to Schema Registry. We'll add this back once we want to integrate again the Schema Registry. And lastly, we have to have the environment variables. Kafka cluster's name is local. That means we are just going to use the local cluster here. And the cluster bootstrap servers, I'm going to provide the address as broker 29092, because here you can see that the Kafka UI is running in its own Docker container, right? And if it wants to connect to this Kafka running in a Docker container, so it has to use the name broker followed by the 29092 port, right? So finally, we also have the Schema Registry environment variable. So I'm going to just comment this out. And lastly, we have this dynamic config enabled as true. This is not really necessary for us to go deep into this configuration. This is specific to this Kafka UI project. So we are just happy by using the defaults here. So once this is done, I'm just going to go to the terminal, and I'm going to run the docker compose up -d command again. And you can see that the Docker containers are all started successfully. So if I go to the Docker desktop and go to the broker, you can see that we don't see any errors, at least for the Kafka container. So let's go back. And also for Zookeeper, we don't see any errors. Looks good. So We have installed, in this way, we have installed Apache Kafka using Docker Compose. So again, if you need something from the Docker Compose file, just make sure to refer to the blog post. Now let's go ahead and install the libraries to enable Kafka integration in our Spring Boot project. So for that, I'm going to the pom.xml file, and the easiest thing we're going to do is to open the browser and open a browser new tab. Go to start.spring.io, and here I'm going to add dependencies. Make sure to select the project Maven and click on add dependencies and search for Spring for Apache Kafka, Spring for Apache Kafka, and also search for test containers. So if you add both of these dependencies and click on explore, you can see the dependencies for Kafka. So the first one I'm going to use is this Spring Kafka dependency. So just copy this configuration here and go back to IntelliJ and paste it somewhere below the dependency of Spring Boot Actuator. And the next thing we need is the dependency for Spring Kafka test. I'm going to again paste this below the Spring Boot starter test dependency. And lastly, we also need the dependency for Kafka test containers. So I'm going to just paste this below the test container MySQL dependency, right? After adding all these dependencies, just make sure to click on the Maven icon on the top right corner to load the changes. So once this is done, the Kafka Spring for Kafka library is downloaded successfully on your machine. So the next thing we are going to do is to configure Kafka in our Spring Boot project. So for that, I'm going to open source main resources folder, and inside the application.properties file, I'm going to add a section called as Kafka properties. So here I'm going to type the property spring.kafka bootstrap servers. This is the address of the servers where Kafka is running. So if the Kafka is running in a clustered environment, you will provide the list of all the URLs of the Kafka cluster. So that's why it's called as bootstrap servers. So as it's only one server running on our side, so we are going to provide the name as localhost 9092. And we also have to define the name of the topic, which we have configured for order service. So we can do that by typing spring.kafka.template default topic, and I'm going to name this topic as order placed, right? And for now, let's go ahead with these two properties. So after configuring these two properties, now we have to write the logic to send out a message from our Spring Boot application to the Kafka topic. So for that, I'm going to open the package, the Java package, and here we are going to send out a message inside the order service, inside the place order method. So as soon as the order is saved to the database, so we have to send the message to Kafka topic. And we have to also decide what we want to send as part of the Kafka topic, right? So as we are sending the message to the notification service, which is responsible to send out emails, the main fields which it requires, it will be the order number and the email, right? So for now, we will just use these two fields to send out an email, order number and email. So for that, I'm going to create a new class called as order placed event. So I'm going to create a new package called as event, and I'm going to create a new class called as order placed event. We can also use a record, but I'm just going to use this as order placed event because going forward, we will replace this class with class which is generated by the Schema Registry. I'm just going to show you the flow of how everything looks like. So I'm going to create a class called as order placed event. This is going to be data, allogs and noaux constructor to just generate the boilerplate code. So I'm going to add a field called as order number, which is of type string, and another field of string called as email. So these are the two fields inside the order placed event. So let's go back to the order service. So here what I'm going to do now is create a object for order placed event. So order placed event equals new order placed event. and I'm going to pass in the email as order.get. So I'm going to pass in the order number. So order.get order number and order.get email. So the email is coming from the order request. So I'm going to provide order request dot user details dot email. So these two events, so the email is coming from the order request user details. So if you're not aware, I think I've added this order request user details as part of the last part where I have added the integration to Angular. So what I'm going to do is I just created a record called as user details, and here I'm going to provide the information email, first name and last name. So these are the details which are coming in from the UI, so that our application has information about the user and not only the order. If I go to the order service, we are just for now using only the email. So I'm created the order placed event object. So what I'm going to do now is to use a class called as Kafka template to send out messages from our order service to the Kafka topic. So for that, I'm just going to first inject the Kafka template class. So Kafka template, and I'm going to call it as Kafka template. And you can see that IntelliJ is showing us a warning that we cannot use raw use of parameterized class Kafka template because it expects a generic arguments. So we have to provide what is the key and what is the value. So key is usually the name of the topic which we are going to send messages to. It's going to be string, and the value is also going to be the value which we are sending, of course, to the topic. So this is of the type order placed event. So we have to make sure to always specify the generic arguments while declaring the Kafka template. So let's copy this Kafka template variable, and just below the order placed event object, I'm going to call Kafka template dot send. I'm going to send a message to the topic. So the topic is going to be order placed, and the value is going to be this order placed object, right? Because as we have defined the key value pair as a string, key as a string and order as order placed event, we have to also send in the same way the key followed by the value. So if I just replace this with order, you can see that it will throw an error because it is expecting a type of order placed event, but we have passed something else, an object of type order, right? So in this way, Kafka template enforces the type safety by just providing the generic arguments. So let's now go ahead and replace it with order placed event, and also let's add some logs. So logged.info is going to be start sending order placed event to Kafka topic order placed, and here I'm going to provide this order placed event and also add a message to inform that the message is sent to the topic successfully by adding this end statement log here. So after adding these two configurations, we need to add one more thing to our Kafka properties. So here we have defined the key as a string and order placed event as a value. So we have defined this in the Kafka template, that's fine, but we also have to define how to read this particular information for Kafka, right? So Kafka will usually send out messages in the form of bytes, so it needs to know exactly in which type we are sending the key and the value, right? So for that we have to define the serializer on the Kafka properties. So for that I'm just going to go to the application.properties file, and here I'm going to define a new property called as spring.kafka.producer.key serializer. So this is going to be the serializer for class for keys. So this is going to be of type string. So for the string, I'm going to use org.apache kafka.common.serialization.string serializer, right? I'm going to use the string serializer class coming from Kafka library, and we also have to define the value serializer. So for that I'm going to define spring.kafka.producer value serializer, and this is going to be org.springframework .kafka.support.serializer.json serializer, right? So we're going to point to the value serializer to the JSON serializer because we are just providing the Java class. So usually we serialize as JSON, so we are providing it as the JSON serializer. So we have to provide these two information, how Kafka needs to serialize this particular information we are sending into the topic. So what I'm going to do now is I'm going to start the order service application, and you can see that the application is started successfully without any errors. That's good. And I'm going to open the UI on the address localhost 4200 and make sure you log into the application. So I'm going to provide my username and password, and here I'm going to order 1 pixel 8. Click on order, and you can see that the order is placed successfully. And if you now go to the order service, you can see some logs. So first of all, let's go all the way up. You can see that we have received the request. So you can see the log start sending order placed event, and Kafka has produce the logs of the producer config. So if you just look at the configuration, it has the bootstrap servers as localhost 9092, and if you just scroll down, it has the key serializer as the Apache Kafka string serializer, and if you scroll all the way down, you can also see the value serializer information. So it's using the JSON serializer. That's good, because it's always useful if something is going wrong in the producer. If you're getting an error, just make sure to check these values so that you know what is the value Kafka is picking up, and if there is some mismatch, then you will know easily that you're doing something wrong. All right, so and we have some information about the Kafka itself, and finally you can see that the end message saying that the order placed event is sent successfully. That means now our application has successfully sent the message to the Kafka topic. Now we can view the messages. We can also verify that the message is really sent to the Kafka topic or not by looking at the Kafka UI. So I'm going to open localhost 8086, and here this is the Kafka UI, and we can configure the cluster here inside the Kafka UI. So I'm going to click on configure new cluster, and I'm going to provide the cluster name as localhost. The host is going to be broker, port 29092, and just click on validate to make sure that the configuration is valid. So as you can see that the configuration is really valid, and I'm going to click on add bootstrap servers. So it's going to be submit, not add bootstrap servers. So we can see that now the cluster is visible here, and if I click on topics to the left hand side, you can see that the order placed event is visible, and it has number of messages as 1, right? So this is the message which you have just placed into the order placed topic, and you can see that in the messages tab we have one message which I have produced. So you can also preview the message. So you can also view the message. So this is the key, this is the value, and you can also produce some messages here. So we'll come back to this later. But there's also possibility to produce messages through the Kafka UI. So this is very useful for you to explore. Now let's go ahead and configure the consumer for this Kafka topic. So in our architecture, this is going to be the notification service. So to create the notification service, I'm going to go again to the website start.spring.io. Make sure that the project I've selected is the Maven project, and the group ID is going to be com.techie.microservices. The artifact ID is going to be notification service, and I'm going to change the description as notification service, and the package name I'm just going to leave it as notification, and let's use Java 21, and in the dependencies we are going to use Kafka, Spring for Apache Kafka. We're going to use test containers. we are going to also use a Java mail sender because we will be sending out emails from this notification service. So that's all you need. So make sure to generate this project. So it will download the notification service to your machine. And let's open this inside the IDE. All right, so we have the notification service. I've opened the service in IntelliJ. So here we just have to first go to the form.xml, and you can see that we have the dependency Spring Kafka, followed by the Spring Kafka test dependency, which is also coming from Spring Boot. And we also have the dependency for the test containers for Kafka, right? And we also have the dependency to Spring Boot starter mail, which adds the functionality to send out emails from our Spring Boot application. So here the first thing I'm going to do is to configure Kafka for the notification service. So for that, I'm going to go to the Spring source main resources application.properties file. And here I'm going to first define the Spring application name as notification service. And let's add the Kafka consumer properties here. And it's going to be spring.kafka.bootstrap servers. It's going to be localhost 9200. And we are going to add a property called as Spring Kafka consumer.group ID. So every consumer should actually define a unique identification ID called as group ID. So if you are a consumer, then you need to have a group ID when you are reading messages from a Kafka topic. To be notification service. And the next property we have to define is going to be the deserializer. So a while back we have defined the serializer for key and value while producing the message to Kafka, right? So in the same way, we also have to inform Kafka how you want to deserialize this information, from the topic. So for that, we also need to go back to the notification service. And here I'm going to type in the information here I'm going to type in the property spring.kafka.consumer.key deserializer. It's going to be org.apache.common.serialization.string deserializer. And spring.kafka.consumer.key, not key but value deserializer, is going to be org.springframework.kafka.support.serializer.json deserializer, right? So we are just using the same classes, the deserializer classes. For string serializer, we are using string deserializer. And for JSON serializer, we are using JSON deserializer. So these are the properties we need also on the consumer side. So now let's go ahead and write the logic to read the messages from the Kafka topic. So for that, I'm going to open source main Java. I'm going to create a new class called as notification service. And I'm going to add this inside a package called as service. So I'm just going to add the package name to the in front of the class, and I'm going to click on the class and click on add. So this will create a notification service class in the service package. And I'm going to add the service annotation, the required args annotation, and the SLF4J annotation from Lombok to add the logging. So here I'm going to first define an annotation called as Kafka listener. So if you go inside, so this is going to be a listener annotation, which will Kafka listener annotation, which will make sure it will start Kafka listener in the background and will read all the messages from the topic which we want to read. So you can provide the name of the topic to the topics field here, topics attribute. So let's go back here, and I'm going to provide the topics value as order placed. So this is going to be the topic which we are reading the messages from, and I'm going to call this listener as listen method as listen. So this listen method is going to take the order placed. So this is the method which listens to the order placed topic. So what we have to do now is also we have to create the class where we can read the messages from the payload, the schema, the class, which is the order placed event class. So I'm going to create this inside a new package called as order, and I'm going to create a new class called as order placed event, right? So, and I'm going to create data, logs and nogs constructor, and I'm going to call this as private string order number, private string email, right? So inside the notification service, now let's add this to the arguments here called as order placed event. And here inside the listen method, what I'm going to do is I'm going to first add a log called as got message from order placed topic, and this is going to be the order placed event. And here what I'm going to do is send email to the customer. So we have to add the logic to send out the email to the customer. So for that we have already added the dependency for Spring Boot starter email. So what I'm going to do now, I'm going to copy some code here into the listen method. So let me add some import here, import class for my message helper, and the mail exception class I'm also going to import. And what I'm going to do now is inject a class called as Java mail sender. So this is the main class which is responsible to send out emails from our Java application. So here what we have is I'm creating an object called as my message preparator, and inside this I'm going to create an object called as my message helper, which is setting the from email address. So I'm just going to give a random email called as springshop@email.com, and I'm going to set the to email address. So this is coming from the order placed event, so we don't need this to string call. And I'm setting the subject as your order with order number is placed successfully. I'm going to use the string.format method to fill in this information dynamically here and create this string. And we are setting the body of the mail as your order with order number is now placed successfully, something like that. And finally we are going to send out the message by using this my message preparator object by just passing it to the Java mail sender.send method. And finally we are also going to log this message, order notification email sent. So this is all we need to send out an email from the Spring Boot application. So this is the actual code which send out the email, but we also if you can observe that there is one error which IntelliJ is showing that the Java mail sender bean cannot be auto-wired because it cannot find any Java mail sender bean. That's because Spring Boot will automatically auto-configure the Java mail sender bean by detecting some properties related to the mails, like the SMTP server related properties. We didn't add these properties yet, so that's why Spring Boot is complaining that there is no bean of type Java mail sender. So for that, what I'm going to do now is I'm going to create another set of properties called as mail properties. And here I'm going to provide the springmail.host, springmail.port, spring.mail.username, spring.mail.password. So we have to provide all these 4 properties. And the question is, how do we get these properties, right? So basically we'll be using some SMTP server to send out emails for us. So this is used to send out test emails from your application. So it's like a email delivery platform to send out emails from your application. So you can sign up. This is free. You can get there is no need to pay anything. Everything is free. So after signing up, you just need to create your demo inbox, and in there you will find the details like the username, password, and the host and the port. So I am going to use this information. So I'm just going to click on this host information. So just copying it by just clicking on this row. So I'm just going to go back and paste this host information. The port I'm going to use as 2525, and the password and the username I'm going to copy, and also password I'm also going to copy this. I will do this off screen. So once you have done everything, so you can go back to the notification service, and you can see that you don't see any errors because now Spring Boot has detected that the Spring Mail properties are defined, and now when you start the application, it will auto wire the Java mail sender bean, right? So in this way, you can configure your application to send out emails. So now what I'm going to do is let's start the application and see if everything is working fine or not. So I'm just going to click on the run application in the debug mode. So we are getting this class not found exception. This is because we forgot to add the dependency for Spring Boot Starter Web, because Spring Boot Starter Web contains all the dependencies to enable the JSON support in our application. So what I'm going to do now is I'm going to add the dependency Spring Boot Starter Web. So this is one of the dependencies we need, because they can see that the class not found exception is coming from the Jackson class, which is everything is there inside the Spring Boot Starter Web. So if I go inside the Spring Boot Starter Web, just for you to know, you can see that Spring Boot Starter JSON is coming directly from the Spring Boot Starter Web dependency. So it's better to use this Starter Web dependency now in our application. So after that, I also made one error. So for the Bootstrap servers, it's not localhost 9200, it's 9092. So let's also change this port to 9092. This is the correct port. And after that, I'm just going to restart the application. Looks like the configuration is not yet configured correctly. So I'm just going to click on reload all Maven projects. So just so that our configuration is reloaded. And if I click on start, you can see that the application is started successfully without any issues. And you can see some messages that a partition is assigned successfully for the group ID. All right, so now let's go ahead and test if this is working or not by opening our UI. I'm going to click on login one more time, and I'm going to now order an iPhone 15. Click on order now. You can see that the order is placed successfully. And if I open notification service, you can see that there are a lot of errors, right? So I'm going to stop this notification service and see what is the issue here. So you can see that error deserializing key or value for partition at offset 1, pass record to continue consumption. So if I just scroll down, you can see that we are getting an illegal argument exception. The class order placed event is not in the trusted packages. If you believe this is the safe to deserialize, please provide its name. So we have to add one more configuration here, and inside the notification service, we are expecting a message of type order placed event, but we did not tell to Spring Boot how to deserialize this message. So for that, we need to add another property called as Spring Kafka Consumer Properties Spring JSON Type Mapping. So we have to provide the JSON type mapping explicitly. I have to provide the reference to the class. We have to deserialize this object. So for that, I'm going to provide the name as event as this is a prefix we have to add, and I'm going to add this com.programming com.techie.microservices.order.event.order placed event. And I have to make sure that I place this order placed event inside a package called comtechie microservices order event package. So previously I added it to the order package. I just now changed it to order event because this is the same package structure as the order service, because in the order service we are using this comtechie microservices order event package. We also have to use the same package here for Kafka for notification service. So once I add this information and make sure that this order placed event is inside the respective package, I can just restart the application. And now let's try to consume this message, produce this message one more time. So I'm going to order this time 2 quantity of iPhone 15, and of course I have to first log in and order 2 quantity of iPhone 15. Order is placed successfully. So if I go to the notification service, you can see that order notification email is sent, right? So our notification service is consuming this message and sent out the email. So let's test if this email is really sent or not. So I'm going to go open Mailtrap, and here you can see that a few seconds ago there is an email. Your order with order number is now placed successfully, right? So this is how you can configure our notification service. And there is one improvement we can do to enhance this notification service is right now you can see that we are constructing the payload, this order placed event messages manually, right? That means we are creating this class manually inside the notification service as well as the order service. So one question I got when I was developing this microservices series previously, 1 year back, was how can we make sure that there is no duplication of the classes in the order placed event as well as the order placed event class inside the notification service as well as the order service. So this is one concern, because now you can see that this order placed event is duplicated across 2 different services. Even though it's fine because these are 2 decoupled services, we can make sure we can use a single point of truth for this schema, for this message. So what we can do is we can create a schema out of this order placed event, and we can use this schema as a reference to generate the class automatically, right? So to do that, we can make use of something called as Apache Kafka Schema Registry. So that's why we need a schema registry to maintain a stable schema of the messages we want to send. So this helps us to make sure that both producer and consumer are on the same page by following a predefined schema. So this Kafka schema registry is provided by the Confluent, by the company called Confluent. So you can see that in the documentation, you can read about schema registry more if you want. So you can see that schema registry provides a centralized repository for managing and validating schemas for topic message data and for serialization and deserialization of the data over network. So this is a best practice which is used usually in the real world projects when we use Kafka. So now, as you can see inside the order service Docker Compose file, we have already added the schema registry. So we are already running the schema registry on the port 8085. So here we are providing the schema registry. We are providing the host name as the schema registry. We are providing the reference to the Kafka Bootstrap servers as broker 29092, and we are registering the schema registry listener at the schema registry port 8081. So by default, schema registry is running on the port 8081. So that's why we have to expose this particular port. So the next question is how to integrate this schema registry into our application, right? So for that, I'm just going to open this application.properties file. And what I'm going to do now is I'm going to delete this particular event class, right? And what we are going to do is we are going to create this particular class from the schema we are going to create. So to create the schema, the first thing we are going to do is we are going to use something called as a communication format called as Avro. So for that, we have to create a file called as an Avro schema file with the AVSC extension. So for that, I'm just going to right click on the resources folder and click on the directory, and I'm going to call this as Avro. And here I'm going to create a new file called as orderplaced.avsc. So this is the format for the Avro schema specification. So for the Avro schema, what I'm going to do now, I'm just going to paste some of the information here. So this is a JSON object of type record, and I'm going to name this as order placed event. The namespace we have to provide where we can find this particular where we want to create this particular class. There's going to be comtechie microservices order event, and the fields which are part of the schema is the order number of type string, email of type string, first name and last name. Right, so these are the schema definition. So this is the schema definition we want to use. So and after that, what we have to do is we have to add some dependencies to enable the schema registry in our application. So for that, I'm going to open the pom.xml file, and I'm going to add some dependencies. To copy these dependencies, I'm going to take help of the blog post one more time. So here I'm just going to scroll up all the way into the area called Spring Kafka, and here I'm going to copy these dependencies: Kafka Avro serializer, Kafka schema registry client, and Avro. So I'm just going to copy these 3 dependencies and paste it inside my pom.xml file. Alright, so we have these 3 dependencies. First one is Kafka Avro serializer. So this adds the dependencies, the functionality to serialize this Avro schema file to the to Kafka, to add the capability to serialize this particular Avro file. And we also have the dependency to register with the Kafka schema registry client. And finally, we also have the dependency to enable the Avro functionality in our application. So finally, we also have to add one more plugin to generate the or order placed event class from the schema file. So for that, I'm going to go back and I'm going to copy this plugin information from the blog post, and I'm going to paste this inside the plugins section, under the plugins section. So just below the Spring Boot Maven plugin, I'm going to add this plugin, this Avro Maven plugin. So what it's going to do is it's going to find the, so we have to provide the source directory where we have the Avro schema file, and what it will do is it will automatically scan this particular Avro schema file, and it will create a Java class, and it will create it inside the source main Java folder under the same package of the namespace. So it will create the class inside this package, right? So now if you try to run Maven clean compile, you can see that we are getting a compilation error because I think the creation of the class is done successfully. So you can see that the class is created successfully, but there is no constructor. So we have to change this definition of the order placed event a little bit. So if you see some compilation error, make sure to reload the, click on this reload all Maven projects, so that Maven, the Avro dependency is applied to your project inside IntelliJ, and you don't get any compilation errors. As you can see now, I have clicked, after I clicked on this reload all Maven projects button, the compilation error is gone. So now I have to adapt this order placed event using the setter methods. So order.get order number, and I'm going to place order placed event dot set email order request dot user details dot email, and you can see that we have also added 2 new additional fields, the first name and last name, and let's also populate this information here. So there's going to be order placed event dot set first name, order placed event dot set last name, order request dot user details dot last name, right? So this is all the information we need to populate before sending out this message to the Kafka topic. So now let's go ahead and do the Maven compile one more time. So this time should not view any compilation errors. Right, so you can see that the build is successful. That means our project has created successfully the order placed event class from the Avro schema file. And we have to do one last thing is we have to change the value serializer. So right now we are using a JSON serializer. What we can do is we can use the Kafka Avro serializer because we are actually serializing in the form of Avro schema, Avro format, but not a JSON format. So for that, what we have to do is we have to change the value serializer to the class io.confluent.kafka.serializers.Kafka Avro serializer. So we can use this particular serializer. So that means our Spring Boot application will so that means Kafka will use this Kafka Avro serializer to serialize this message into a Avro format. So this is one thing we need to keep in mind. And we also have to define the URL to refer to the schema registry where this schema will be registered. So for that, I'm going to call spring.kafka.producer.properties.schema.registry.url is going to be http 127.0.0.1 So after adding all this information, so what I'm going to do now is I'm going to restart this application, and you can see now that the application is restarted successfully. So now I'm going to go back to the UI, make sure I log in one more time because it's going to be expired. The token is going to be expired. I'm going to provide the quantity as 1 and click on order now. And you can see that the order is placed successfully. So also see the confirmation message inside the order service class. So let's open now the Kafka UI and see if the message is visible or not. So if I just go to the messages, there are actually 4 messages. This is the latest one which I have. So this is the latest one which I have created. So you can see that all the previous messages are in the form of JSON. But if you click on here, you can see that it's using a different format, using an Avro format. So this is one difference you can already see. But now if you go to our notification service, maybe you can see that it's screaming out loud that it cannot understand what this message is about. So for now, just stop this service and let's understand what is the issue. So you can see that it's not able to identify, it's not able to deserialize this particular message from the notification from the order service. It's because we have provided the deserializer as a JSON, but what we are really sending is like a message in Avro format. So what we have to do now is we have to change this deserializer, but before that we also have to add the Kafka registry and the Avro dependencies also in the notification service. So let's go to the order service, and I'm going to copy all the dependencies here from order service to the notification service. So this is going to be the Avro dependency, schema registry client, Kafka Avro serializer. All these 3 dependencies I'm going to copy and paste it just below the Spring Kafka dependency. And I also have to copy the plugin. So this plugin is going to be Kafka. So this Avro Maven plugin, I'm going to paste this inside the notification service. Just under the Spring Boot Maven plugin, I'm going to paste this Avro Maven plugin, and this is going to be the same configuration. There's nothing needs to be changed here. And one thing I'm going to do now is to create the schema file also inside the notification service. So for that, let's open the order service. And also copy this Avro folder as it is and paste this inside the resources folder. Click on add. You can see that we are using the same schema file here. And now we are just click on the Maven icon and click on reload all Maven projects so that the Avro dependencies and all the dependencies are downloaded successfully to your machine. And now I'm going to open the application.properties file, and here I'm going to type io.confluent kafka.serializer.kafka Avro deserializer. So this is the configuration I need to provide, and I also have to provide the URL to the schema registry. So there's going to be spring.kafka.consumer.properties.schema.registry.url equals to http localhost 8085 127.0.0.1 8085, and the last property is going to be spring.kafka.consumer.properties specific.avro.reader equals true. So we have to also provide a hint that we are using an Avro reader to the Kafka consumer. So that's why we need to add this property. So now if you go ahead, so that's all you need to do, and we can actually delete this particular class, and because the Avro Maven plugin will actually create this for us. So what I'm going to do now, I'm going to click on Maven clean compile, and you can see that order placed event is now created successfully without any compilation errors. So of course we have to maybe adapt this order placed event one more time. I have to import this class one more time, and I have to change this order placed event to get email dot to string, because by default it's using a character sequence type. Now we just have to change it to a string. Right, so now you can see that the order placed, we also have the information about first name as well as the last name inside the schema. So what I'm going to do now is I'm going to add some more information to the email. So I'm going to add two new fields here, so the first name and the last name, and I'm going to populate this and I'm going to add a placeholders for this string, and I'm going to populate this using the order placed event dot get first name dot to string and order placed event dot get last name dot to string. So in this way we can adapt the email so to display the first name and the last name. So now let's go ahead and start this application and see if everything is working fine or not. And you can see that the application has started successfully, and as soon as it started, it understood that there are some pending messages in the topic, and it's automatically sent out this particular email. Right, so now let's go back to now let's open the mail trap platform, and you can see that a few seconds ago a mail was sent, and now you can see the first name and last name also in the email. So hi test user, your order with number is placed successfully. Right, so this is the functionality we have added also on the notification service. So we saw how to install Kafka using Docker Compose. We saw how to create a producer. We saw how to create a consumer. We saw how to also use Kafka schema registry to make sure that the schema changes are replicated correctly across producer and consumer. And the last thing which is pending is the integration test. So I will have a link to the so I will add this integration test in the blog post. So to make sure that you check out the integration test and make sure to write the integration test on your own. And that's it for this video. I will see you in the next video, where we will see the concepts of observability, of how to implement logging, traces, and monitoring in our Spring Boot application. I will see you in the next video. Until then, happy coding techies.